Okay, guys, so I think I can start the lecture now. Good afternoon, everybody. So first of all, there is something I want to say about tomorrow's test. So here, let me come to the slides here, okay. In C language, here in this slide, I explain how can you display a digit on the 7th segment in C language. Is that okay? So I told you we can do something like that here. So this is similar to what we did in assembly. We can do array like this one. And then if your number is 0, so I have to get digits of 0, which is this one. I have to put this one on port B. Is that right? If your number is 1, so I have to get digits of 1 and so on. 9, so it has to be this one. Is that okay? So this was one approach I explained. There is another approach I also explained. I told you this is like a very quick approach. However, I found the problem here. I want to pay your attention to this problem, okay? Luckily, I explain the same thing by different ways. So if one way doesn't work for some reason, you can use another way, okay? So let me clarify here. So I told you here, guys, in this function, segment 7 decimal, you don't need to convert the number to a 7 segment code. You don't need to do that, okay? All what you have to do, just send the number to the function. The function is going to do the conversion internally. It's going to do everything internally. However, there is a risk here. I explained last time the risk. The risk is for port P. For port P, we use the first. We use the first 4 pins, PB0 until PP3. We use the first 4 to enable or disable 7 segment, as you know. Okay. So also we use the 3 bits here, PB4 to PP6. We use them for RGB. Is that okay? I told you most of the programs written here, I don't consider the RGB because the program doesn't have RGB. Is that okay? That's why I just write something to port P, move to port P. Okay. I told you even the same thing in assembly here. So most of the time I did like something like that. Here, I just move some value to port P, which is okay because I'm not using RGB here, right? However, if you are using RGB here, this will make trouble because every time it's gonna interfere with the RGB, right? So that's why I told you either use assembly or use C. You have to be careful here. Don't use something like move, otherwise you are gonna write in the whole port. This will interfere with the other ones, with the RGB. The best way to do it is just using bit set, bit clear, to just manipulate the exact bits you want to manipulate. Is that okay? I made it very clear about this one, okay? However, there is something tricky here. The tricky part is if you use this function, because you don't see what is inside this function. If you use this function, it's not going to work. Why? Because inside this function, they make this problem. They just move to port P. Is that okay? So I'm going to show the problem here. So yeah, so if you go inside this function, you will find here, this is the code for this function. You will see here, we just write to port P. Is that okay? That means some student contacted me yesterday. So he told me, look, it doesn't work because every time you enable some 7 segment, you manipulate also the RGB. So there is interference between them. Okay. So how can we handle it? Very simple, very easy. So the way you should handle the tricky part is that just this problem is hidden because it's inside the function. You don't see you just use the function, okay, and then it doesn't work. So it's just hidden. However, how can you handle it? Very simple. All what you have to do, guys, don't use this function if you are using C. Okay. All what you have to use, you have to do. Number 1, you have to do something like this, like as I did here. You have to use something like this, guys. This is number 1. Number 2, for example, I can say port P is equal to digits And then I'm going to put here the number I want to put in port B. This is number 1. So number 1, you can do this part here. Okay. So the number, you should get the code from here. So this is the number, for example, this is the number you want to display. Okay. So the number you want to display, put it here. Okay, as you see here. And now I'm going to get the corresponding value here. So if this number is 0, I'm going to get this one. 1, 2, 3, 4 until 9. So I'm going to get this value. I'm going to put it in port P. This is number 1. Okay. Number 2, you have to enable one. We have to enable one 7 segment and disable the other one, because we're going to use only 2, right? We're going to use only 2 7 segments. For example, here, this one has PP0. This one has to PB1. Is that okay? Assume for sure the least significant number has to be here. The most significant number has to be here. Is that okay? So for example, if this number is the least significant, so you have to write after you put number 2, you have to put here 0 and you put here 1. And that's very simple. Bit set, bit clear. That's it. Is that okay, guys? Bit set, bit clear. That's it. Any questions? Okay. Also, because we have here time multiplexing between 3 things, not 2. We have time multiplexing between 3 things. The 3 things are PB0, PB1, and also we have BG1 for the LEDs. So time multiplexing here between 3 things. Okay. So I display this number for some time, and then I turn this one off. I display this this number for some time, turn it off, and then I display the LEDs for some time and turn it off. Is that okay? So very simple. So, and every time, for example, if I want to use this one, I have to make sure put here 0, put here 1, and put here 1. Okay, very simple. Bit set, bit clear. Okay, don't use move. Bit set, bit clear. Okay. Otherwise, if you use move, are gonna interfere with RGB. If you wanna put the number here, put here 0, 1, 1, or you put 0, 1, 1. Is that okay, guys? Any questions? Is that clear? Anyway, so I'm not sure anybody here finishes a program in C language. Yeah. Do you have a problem? Because I told you sometimes you have this problem. Sometimes, not all the time. When you say RTI-CTL equal whatever, sometimes for some reason it does not accept it, but it worked with you. You were able to change. You hear 2 different tones. Okay, so it works. Yeah. Again, for some reason in some ports it didn't work, so it doesn't work. We already have some plan. So we have backup plan. But for now, you can just try it this way and see if it's gonna work or not. Okay. Before I start today's lecture, do you need any help before tomorrow's? Yes, it is a test, but still I want you to understand it very well, because this test has too many things I explained here in this class. So I think it's very important. So I want you to understand it. So do you have any question, anything I can explain here before I start the lecture? Same thing for the Zoom students. If you want me to explain anything in the test, it's not clear, you can talk to me. It looks too easy, okay? So I'm gonna ask the TE to be strict in grading. Okay. Anyway, that's okay. I just want you to learn, okay? And I think this test is important to learn, because we're using the main program. We're using the 2 interrupts. Okay, this is number 1. Number 2, we are using time multiplexing. Okay, we are using the buzzer. We are using also the concept. How can you enable or disable interrupts? And what is the meaning if you disable interrupts? Because as I mentioned here, interrupt, I'm using RTI to make the alarm sound. Okay, so if you don't want to hear the alarm sound, simply who is making the sound? RTI. So you should disable RTI. Very simple. You got what I'm saying? So it has a lot of things. Also, when you read port H and manipulates bit manipulation for port H, so it has a lot of things to learn. Okay. Anyway, so the second thing for today, I'm gonna continue what I'm doing here in this chapter. Okay, so last time I was explaining this program, guys. No, this one. Yeah, so I told you in this program what I want to do here, guys. IRQ. Okay, so here I wanna count how many interrupts IRQ is received. Okay, So I have a counter. It's like a counter. This counter should count how many interrupts IRQ received. But why? Why you want to do something like that? The reason, as I told you before, is I'm going to give you several applications. Okay. Number one, as I told you before, we can have like here infrared transmitter and the receiver this way. Okay. And this receiver, I can connect it to IRQ. Okay, so for example, for sure it depends on the electronics how it is connected. But for example, this one is high all the time. When someone just interrupt this line, okay, it can be a person entering the store. It can be a car. If I wanna count how many cars, whatever. Okay, whatever it is. Okay, it can be a person gonna hit it. Okay, anyway, so every time someone enter here, you are gonna trigger signal like this one. Okay, so if I want to count how many cars passed the way, or how many person entered the store and so on. Okay, so all what I have to do, guys, I have to count how many every time I receive a pulse. That means it's one person. Is that okay? So this is one idea to why sometimes I need to count. Another idea I also explained last time, it can also used for motor. I'm going to give you details in chapter 5 to measure motor speed. Okay, the idea of motor speed is usually you have a disc like this one. As I said last time, this disc can have 2 holes or maybe more, but now assume it has 2 holes. It's connected to the motor, so it rotates, but this one rotates between same thing. So you have here transmitter and the receiver. Okay, so if you look at the signal here, you can see something like that. So here, when the hole, every time the hole comes here, so there is a light is going to hit. And if the light hit, for example, I'm going to get 0. Again, maybe last time I did this way, okay? It doesn't matter because it depends how the electronics is. So it depends how you connect the electronic circuit. So this way or this way, it doesn't matter how it is, okay? It depends on, and I can use both of them. Anyway, so it depends on how the electronic circuit is, okay? So here I'm assuming that's what I'm going to get here, okay? So every time it is, here for sure, this part, you are gonna there is no light is gonna hit the receiver on same thing here. That's why here I'm gonna have 5 and 5. In this hole I'm gonna have this pulse. In this hole I'm gonna have this pulse this way. Is that okay? So in this case, every 2 pulses it means 1 rotation. They call it 1 revolution, I guess. Okay, 1 revolution or one complete rotation. Is that okay? So if I wanna measure the speed of the motor, all what I have to, I need to count. That's exactly what this program is about. So I need to count how many pulses I got here. Remember, every pulse here, if I program IRQ to trigger at falling edge, so it's gonna be triggered here, as you see here. So every pulse is gonna trigger IRQ 1 time. Okay. So anyway, so I need to count how many pulses I have, for example, in 1 second. Okay, and then I have to divide this number by 2 because every 2 pulses means 1 revolution. This is how I can measure how many revolutions per second or per minute, whatever how you calculate it. Is that okay? Very interesting. So what I can do now, this is interesting. You know why? Because I need timer to count for 1 second or 1 minute, and I need IRQ to count for how many pulses we have. You got what I'm saying? So I need to enable. I'm going to enable IRQ interrupts to start counting, and then after 1 minute or 1 second, whatever you want to measure it, after 1 minute or 1 second, I'm going to disable IRQ, and then I'm going to see what is the number divided by 2, and this is the speed, number of revolution per second or per minute. Any questions? Okay. In one test like test 2, like the one you did, in one test, I asked the students to use another idea to use the same program here. I'm going to teach right now. I want to use this program as a frequency meter. And what we did was we got a function generator, and then we connected the output of the function generator this way. We connected it to IRQ. Okay, and I want to measure the frequency. What is the frequency? Frequency means how many cycles per second. Is that okay? And in every cycle we have one falling edge. That means we have one interrupt in every cycle. You got what I'm saying? So it's the same idea. So if you see something like that, so here, I'm sorry, I think we have here, so from here to here, yes, we have only one falling edge. And then from here to here, we have only one falling edge. Everything is recorded. Anyway, I'm gonna sleep. Anyway, so what I'm saying, guys, here, I want to give you different ideas why sometimes I need to count the number of interrupts. Okay, so here, for example, I wanna measure the frequency. We did this one, like it was like test 2, and we compared the number I measured by the number shown on the function generator. Okay, so the idea here, it's exactly same idea, because we're gonna have one IRQ interrupt for each cycle. So every cycle we're gonna have one IRQ. Okay, so all what I have to do is, what is frequency? Frequency means the number of cycles in 1 second. Is that right? This is hertz. This is the meaning of hertz. Okay, how many cycles per 1 second? So it's the same thing here. I need to measure how many interrupts I have in 1 second. Is that okay? So it's the same thing. So that's what I want to do here in this program, guys. What I want to do in this program, I want to count the number of interrupts I'm gonna receive. This is number 1 on IRQ. Number 2, so it's a counter, okay? Not timer, it's a counter. Number 2, I want to display this number on the 7th segment, okay? As you will see in the video right now. So because I'm gonna connect a jumper as we did before. So every time I press a button, so I trigger IRQ interrupt, and you see the counter incremented by 1. You got what I'm saying? So you can see here the counter incremented by 1. So that's what we want to do here. So two things here, we need 2 tasks here, 2 tasks. The first task, I need counting, and counting is done by IRQ. So I can use IRQ for counting. Okay, that's okay. I can use IRQ for counting. What else do you need here? I need time multiplexing. Because I'm going to use two displays. So I need time multiplexing. As I explained before, you can do the time multiplexing. You can put it in the main program, or you can use RTI to do the time multiplexing. So whatever you like, both are okay. Okay. I think here, I decided here to do it using RTI. So I'm going to do the time multiplexing using RTI. Okay. I think I explained it before. It's very simple. What happens is that, for example, if I want to display number 332. So, and this is IRQ. This is RTI. So in one interrupt, I'm going to do this one. Next interrupt, I'm going to do this one. So this interrupt 1, interrupt 2, then interrupt 3, interrupt 4, interrupt 5, interrupt 6, and so on. So one interrupt, I'm going to do this one, one interrupt this one, one interrupt this one, one interrupt this one. Okay. So you have to make sure the time between each 2 interrupts, as I said before, it should not be too short. Otherwise, they are going to become dim. Also, it should not be too long, because if they are too long, like 7F, if we use 7F, which is 131 milliseconds, this is a long time, they are going to become, you will see flicker. Okay. That's why if you look here, what I did here, guys, I used 10, number 10 instead of 7F. I explained it before anyway. Okay, so let's see how it works. You understand what I'm saying? What we want to do right now? So what I want to do now, I want to use IRQ to count the number of interrupts. This number 1. Number 2, I want to use RTI for time multiplexing to display the counter. I want to display it. Okay, I think it's better before I show you the program. And also one more thing here. I'm assuming I want to count from 00 to 99. That's what I assume. So after 99 should be 00 again. Okay. So I'm going to use only 2 digits. That's why I'm asking you here. Yeah, after I finish, I'm asking you, can you extend this program to use 4 displays? Yes, for sure you can, right? But here I'm going to use 2 displays. Can you extend it to do 4? Yes, you can do 4. Okay. So again, here I'm assuming I can count from 00, 1, 2, all the way until 99. After 99 should come 00 again. You have to reset it again. Okay. So before I show how the program is written and how can you do it, I want to show the video. It's very interesting. After that, I'm gonna explain the program. Yeah, here. Yeah, this is counting. Look here, guys. Every time I press the button, okay, so I trigger IRQ. When I trigger IRQ, you increment the number. You can see here. Okay. Okay. So let's see how we can do it. Very simple. So the way you are going to do it is, again, very useful program. So I told you, at least I mentioned 3-4 application for this program. Okay. So number one, as we always do, you have to do initialization. Here, the initialization I'm going to do, this is for RTI, this is for IRQ. That's what we always do. This is number one. Number two, you should have this table, right? So this should give me the code for the 7th segment. Okay, this is number two. Number three, I'm going to use here, guys. I'm going to use here also these two numbers. This number, I'm going to put them on port P. This is a number to enable. So if you look at this one, what this one is, this should be 7. 7 means 1110, right? But if you look at, that means this one is enabled. So the one that has 0, because I'm going to put this number on port P, okay? So this one should be B. B is 11, right? B is, yeah, 11. So how can you get 11? It's 80111, right? Yes. So now this one is enabled. So if I put this number on port P, so I'm going to enable this 7th segment. If I put this number here, I'm going to enable this 7th segment. Is that okay? So what is going to exactly happen is, look here, guys, in one interrupt, very simple. In one interrupt, I'm going to send this one to port B. In one interrupt. Next interrupt, I'm going to send this one to port B. Then next interrupt, I'm going to send this. So one interrupt here, one interrupt here, one interrupt here, one interrupt here. Is that okay? So one interrupt, I'm going to enable this one, and the other one is disabled. Okay. And then next interrupt, I'm going to enable this one. Then enable this one. Enable this one. Okay. That's why I'm going to send this code to port B. Every interrupt. So now the question is, this should be done inside RTI, as you will see right now. Okay. So one interrupt, I'm going to send this one. One interrupt, I have to send this one. So how I can know if I should send this one or this one? How I need a counter. That's why I have here I have a count here, guys. So this count should have the value of 0 in one interrupt, then 1. If it is 1, I'm gonna make it 0. So that next time it is 0, 1, 0, 1. So that's how the value will be. Okay. So the counter 0 should have only 2 values. 0. Increment, it is 1. Once it is 1, so it should be 2. No, I'm not gonna make it 2. Once if it's 2, I'm gonna make it 0. So that this is a pattern. This is a pattern I need. One interrupt, it is 0. One interrupt is 1. One interrupt is 0. One interrupt is 1. One interrupt 0. One interrupt is 1. Is that okay? Why you made it this way? Very simple. Simply because if it is a 0, that means I know that I have to take this value. This okay, and also I have to output digit 1. If it is 1, that means this time I have to output digit 2, and then I have to take this value. Is that okay? As you will see right now how I made it, you will see. But now, this is a question. I have the question very simple. Look here, guys. In one interrupt, I have to output this one, and also I have to output digit number 1 on port P, okay, and this one on port P. And in another interrupt, in next one, this one has to go to port P, and I have to output digit 2 on port B. Is that okay? So how I can know if this time it should be here or this time it should be here? Okay, I'm using counter. So if the counter is 0, I'm gonna do this one. Every time the counter is 1, I'm gonna do this one. That's why it is 0, 1, 0, 1, 0, 1, 0, 1. Is that okay? Now, If you want to extend this program to make it for 4 instead of 2, I'm going to make it 4. How you would change it? Number 1, counter, it should be 0, 1, or 2, or 3. After that, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Okay? If it is 0, I'm going to take this 2. If it is 1, I'm going to take this 2. If it is 2, I'm going to take another 2. If it is 3, I'm going to take another 2. You got what I'm saying? Because I have four numbers. Anyway, so let's explain on 2 now. Focus on 2. But I just want to tell you, in this program, I explain on 2 7 segment, but it's very easy if you want to extend to 4, okay, or 3. Okay, but anyway, you will see right now what I mean now. Okay, so now here I made an array, as you see here. This array I called it digits. Okay, every digit should have a number. As I told you, for example, this is the count. For example, if the count is 19, so as you see here, guys, this should be 2 memory location. 1 memory location at digits, and the second memory location at digits plus 1. This is the address, right? So the address digits should give you 1 byte. Digits plus 1 should give you another byte. Is that okay? All what you have to do, listen to me. In IRQ, I have to put the number, the count here. For example, it is 11. Now it is 11. IRQ is interrupted. So IRQ should make it 12. Okay, assuming this is the most significant. Okay, interrupted. So IRQ has to make it 13. So this is 2 memory locations. Every time IRQ is interrupted, IRQ has to increment these decimal numbers. These numbers are decimal. Is that okay? And then RTI is gonna take them to display them. So who's gonna update them? IRQ. Every time IRQ is interrupted, it's gonna update the count. Okay, here these 2. Who's gonna read them and display them? RTI. Is that okay, guys? So I have 2 memory locations. These 2 memory locations should store the count, the number in decimal. Okay. So for example, this 30, then 301, 302, 3, 4, 5, and so on. Who's gonna make this one? IRQ. Who's gonna take these values and display them in the 7 segment? Who's gonna do that? RTI, as you will see right now. Okay, so let's see. Let's go to the details. So now, this part is just initialization for 7 segment. So I'm not gonna talk about them. Also, you need to do initialization for port H because I'm gonna use the push button. Also, you enable here IRQ. Here, these 2 for RTI. We always do that. The only difference is, by the way, this is a common mistake between students because most of the programs we use 7F. Most of the program. Remember, 7F means 131 millisecond, right? So if you see flicker, that means the time is not correct. So you should not use 7F. We use 7F if you want to make 1 second, because every 8 interrupts can make 1 second. So it's going to be easy to do this way. However, here I used a different number, okay, smaller, slow, okay. So anyway, and then here the main program is empty, as you see here. Most of the time I'm going to loop here. So the main program is empty. You can write whatever you want to write, okay? So most of the time we're going to loop. If there is interrupt from IRQ, I'm going to go to IRQ and return it back. Otherwise, if there is interrupt from RTI, I'm going to go IRQ and come back. So all the time, that's how it is. All the time the program either looping this way, or go IRQ and come back, or go to RTI and come back. That's it. Any questions? Okay, so let me tell you the details. Very simple. So the details is, guys, look here. We have 2 memory location. 1 memory location, one of them, we have 2 bytes. One at the location digits, the other one at the location digits plus 1. Okay, these 2 addresses. Okay, IRQ should put the count here. The count. So every time IRQ is interrupted, I'm going to increment this count. So 27, then it's going to make 28. Okay. And these numbers, although everyone is a byte, it means it can take a value from 0 to 255. No, I'm gonna give the format of everyone in decimal. That means every one of them should take a number from 0 to 9. Okay, you will see right now after I convert, you see conversion now. Anyway, so who's gonna update these 2 memory location? IRQ. Okay, now RTI is gonna take them to display them. How? It's gonna, in one interrupt, I'm gonna take this one with this enable, with this one, okay? Second interrupt, I'm gonna take this one with this one, okay? Who's gonna help me if this is interrupt 1, 2, 1, 2, 1, 2 count, as you will see right now. Let's go to the details. So let's go to first IRQ, okay? So this is how I made IRQ. Look here, guys. Here I used a memory location, I called it number, okay? So here I used a memory location, I called it number. So every time there is an interrupt, so this is the count. But this is the count, listen to me, because this is an important thing. This is the count in binary. This is the count in binary. Is that okay? So this is a binary byte. This binary byte can take a value from 0 until 255. However, I told you because I'm gonna force it to be until 99. I'm gonna force it. Once it is 99, when I increment, I'm not gonna allow it to go to 100, okay? Because I put a limit, okay? Yes, it is binary. It can go to up to 255, but here I wanna force it to be between 0 to 99. I wanna do that, okay, because I have to, in my application. That's why if you see here what I did here, guys, number one, you increment the number. This is number one. Number two, you compare it to 99. If it is less than 99, okay, I'm totally fine. Go and convert. If not, clear the number. Is that okay? Yes, it is a byte. This byte can take any binary number from 0 to 99. Is that okay? So what else? Yeah, so every time, as you see here, guys, in this part, every time IRQ is interrupted, you increment the byte, okay? And then you check. If it is 99, when you increment to 99, I'm gonna go to 0, 0. Any problem here? What else I have to do now? What else? I have to convert the binary number to decimal, as you will do tomorrow. Why? Because simply because you are still confused about this, but I'm gonna give you a very simple example. If I have a byte like this one, guys, look here, 0, 0, 0, 0, okay? Then I have 1, 1, for example, 0, 1. So this one should be 8, 4, 1, right? So this one should be 13, number 13. Is that okay? So this is number. This is number, okay? So number should be binary like this one. Is that okay? However, if I want to display this number on the 7th segment, I have to convert this number to decimal. That means I'm going to take this number. I have to do some operation here. I have to do some operation. And then after that, I'm going to, from this number, I'm going to extract 1. I'm going to extract 3. I'm going to put 1 in digits, in location digits. I'm going to put 3 at digits, all the opposite, it doesn't matter. So I'm going to put one of them at digit, the other one at digit plus 1. And then RTI is going to read them here. So that's what we call, guys, here what I did binary to decimal conversion. Binary to decimal conversion. Is that okay? Understand the story now? Okay. So now, how I can do this? How I can do this conversion? Okay. The way you can do this conversion, guys, as I told you before, just divide by 10. So this number is 13. When I divide by 10, the quotient should be 1. Remainder should be 3. So now you have 1 and you have 3. That's it. Okay. Here I need to divide only one time. However, if you have more digits, okay, for example, if the number is 255, if you have 3 digits, so you have to divide 2 times, as you will see right now. For example, I have 251 this way, for example, okay? I have 3 digits, so I have to divide 2 times. How? I'm going to tell you how. First, I'm going to divide it by 10. The quotient is 25. Remainder is 1, so I already got 1. Then I'm going to take the quotient, I'm going to divide it again by 10. Okay, so when I divide this one by 10, I'm going to get another quotient, which is 2, and I'm going to get remainder, which is 5. Okay, so I have to keep dividing by 10 this way. Okay, you understand the idea? Number one, you should understand what I'm doing here. What I'm doing, I have a binary number, and then I'm going to extract the decimal numbers. Is that okay? Why you have to do that? Because if I want to go for LCD, I should have the decimal numbers. Okay, so I cannot, as I thought before, I cannot give this binary number to the LCD, right? As we explained before. So all what you have to do, guys, from this number, you have to extract these 2 digits, and then you have to convert them to ASCII, and then you have to send them to the LCD. Okay, here I'm gonna do the same thing, but I'm not gonna convert it to ASCII. I'm gonna convert it to the 7-segment code. So once I get 1, I have to go to this table here to get this code, right? And then send it to port B. If you get 7, so you have to go to 7 here, or 6, or whatever. You got what I'm saying? So anyway, it's the same thing. After you get the digit, after you get the decimal number, in case of LCD, you have to convert it to ASCII, but in case of 7-segment, you have to convert to 7-segment code, okay, using the table I have here. So let's see how I made it. Very simple. Look here, guys. So number 1, this is IRQ. So every time IRQ is interrupted, so I'm gonna, as you see here, I'm gonna increment the binary number, and now I'm gonna do the conversion. Look how I did the conversion, guys. So here, I'm gonna put this number in register B, and then I'm gonna clear A. So now I have register D, okay, because I'm gonna use IDEF, and in case of IDEF, it has to be a word. So what I'm gonna do here, in register A, I'm gonna put 0. In register B, I'm gonna put the number here. Is that okay? Because I'm quite sure the number should be between, up to 99. 99 means byte. Byte should be enough. Anyway, so and then, so now register D has the number. Register X, I'm gonna put 10 in register X, as you see here. Now I'm gonna divide. So now I'm gonna divide, as you see here, I'm gonna divide register D, the number by 10. Okay, I'm gonna divide it by 10. And then the quotient should go to X, the remainder has to go to D. Okay, actually, although the remainder has to go to D, and the quotient in D here, D, as you know, D should be 2 parts, A and B. Actually, although I put the remainder in D, actually it's gonna it should be B should be enough, because I'm quite sure the remainder is less than 10. So the remainder is a number between 0 to 9. So byte should be enough. So although it is stored in a word, but just I'm gonna only use B. That's what you see right now. So now after I'm done, look what I did here, guys. I'm gonna move B to digits, because the first number is at B. Is that okay? Don't be confused. It is at D. It's at D. It's correct. However, because this number is small, it should be at B. Okay, as I did here. This is the first number. The second number is as you see here. It is at X. So I'm gonna move it from X to D and then do the same thing again. So I did exchange as you see here, so that I want to move X to D, and then I'm gonna take B, put it at digits plus 1. Any questions? So every time there is IRQ interrupt, I'm gonna increment the counter, I'm gonna do the conversion, and now the recent number is at digits and digits plus 1. Okay. Now RTI should use these 2. Any questions? Okay, let's go to RTI. So here in RTI, guys, as you see here, the way I'm gonna do it, for sure, what I have to do here in RTI, guys, I have 2 memory location. I have digits, and I have digits plus 1. Is that okay? Also, I have here the enable. I have enable, and I have enable plus 1. Is that okay? So this is the enable, and this is the enable plus 1. Is that okay? So the way I'm gonna do it is, I'm gonna make, for example, register X is here. Register X is here. And then if I X plus count, and as I told you, count is 0, 1, 0, 1. So in one interrupt, I'm gonna take X plus 0. Next interrupt, X plus 1. Okay, then X plus 0, X plus 1, X plus 0, X plus 1, and so on. Got what I'm saying? Because of count. So this is exactly what I did here. So what I did here, as you see here, guys, X is gonna point at the first location here. Same thing for digits. You know, digits, we have 2 locations for digit. We have digits and digit plus 1. It's the same idea. I'm gonna use here Y, y is pointing here as you see here. Then I'm gonna add count. Okay, so what I did, guys, let me come here to explain it better. Look here. X is here. Y, this one should be two location. So Y is here. Is that okay? All what I'm gonna do is X plus count and then send to port P. Okay, the byte pointed by X plus count, Y plus count, and then send to port B. That's it. Okay, and because count 0, 1, 0, 1, 0, 1. So one time I'm gonna take this one, next time I'm gonna take this one. One time I'm gonna take, when I take this one, I'm gonna take this number. When I take this one, I'm gonna take this number. Is that okay? Something may happen, listen to me, it's not a big deal, but or it's just a very small thing you can fix. Look here, guys. What happens is that, for example, if the number is 13, however, when you display it, you see it like 3, 1. You know what mistake you made? It should be 1, 3. But when you display it, you see it 3, 1. What happened is that you have to use 1, with this display, and you have to use 3 with this display. So when I use 1, I have to enable this display, right? However, you did the opposite. Right? So when I put 1 on port B, I enable to this one. That's why it opposite. Okay, so very simple. So the way you have to do it, you have to look at the enable, just to correct the enable. Okay, or you can correct the number. You can leave the enable but correct the number. Okay, so when you use a certain number, I have to enable the corresponding 7 segment, right? Otherwise, they are going to be switching. Anyway, so as you see here, guys, X is going to point as this one, Y is going to point as this one, as you see here. I'm going to put count, I'm going to put it in register B, and then I'm going to add Y plus B. So this one is going to be Y plus B, and B is count, so Y plus count, okay? And then after that, as you see here, I'm going to read the location pointed. So here, this one here, Y should equal Y plus count. Okay, and then I'm going to read the byte pointed by Y. I'm going to put it in register A, as we see here, and then I'm going to take the corresponding number here. I'm going to put it in port B. Here, look here, guys. So because another thing here, once you have here a number, look here, guys. I have a number here, right? I have to convert this number to a value here. Is that okay? So I have to convert this value to a 7-segment code. How can you do it? Very simple. As we did before, register X is here. Okay, so all what I have to do, X plus the number here. That's it. Because if the number is 0, so I'm X plus 0, I'm going to get this one, X plus 1, X plus 2, X plus 3, and so on. So how can you do it? As I explained to you before, the way you have to do it, guys, it should be A, comma X. And X should be here. X should point here. A should come from here, the digit. Which digit? Is that okay? That's what I did. So what I did here, guys, Y, we have two values for digit. Y is pointing here. Okay, then I'm gonna add count. So now if I'm gonna add count, so now if count is 0, I'm here, count is 1, I'm here. Okay, so and then I'm gonna read the value here, point, because this is address. So I'm gonna read this value, I'm gonna put it in register A. So now register A is holding a number, a decimal number. So for example, if it is 13, so register A now has 1 or it has 3, depends on the value of count. Is that okay? Now, then I'm gonna use A comma X to read, to convert this number, okay, to code. Then I'm gonna send to port B. So now I'm done with port B. So what should I do now? What you have to do now, I have to enable the 7 segment. Okay. So now I got one number. So exactly what happens here, when count equals 0, 1, 0, 1, 0, 1. Every time it is 0, I'm gonna get this guy here. When it is 0, I'm gonna take this byte, and then I'm gonna convert this number using A. I'm gonna take it, put it in A, and then I'm gonna use A comma X to convert it to a code sent to port B. Okay. When it is one, I'm gonna take this one. Okay. So anyway, so now I am done with port B. So now I have to do port P as well. Okay. So let's see how can you do it. It's the same thing as I told you. All what I have to do here, guys, is register Y or X, whatever you want to call it, Y or X is going to be here, plus count. That's it. So if count is 0, I'm going to take this one. If count is 1, I'm going to take this one. Okay. That's what so as you see here, guys, X. So I'm going to initialize X. Count, I'm going to put it in A, counting. And then I'm going to take the location X plus A or X plus count, because A has count. I'm going to send to port P. Is that okay? Okay, so let me make it very simple. For digit, I have 2 numbers. For enable, I have 2 numbers as well for enable. Okay, when count is 0, I'm going to take these 2 numbers. This one is going to go to port B. This one is going to go to port P. When count is 1, count is 0, count is 1. I'm going to take this one, and then I'm going to take this one. Okay, and then repeat. That okay? However, listen to me. So now, if you are using RG, here I'm not using RGB, so I don't have any problem. So because I'm gonna write everything here to port P, right? So if you are using RGB, so now you are gonna have trouble, right? Because you are gonna change the RGB. So what can I do? Very simple, and that's what you have to do tomorrow. All what you have to do, guys, instead of writing this part, okay, or even using this one. So in this case, I don't need these ones. Okay, I'm gonna do it, but listen to me because you need it tomorrow. Okay, so the way I can do it here, guys, I can compare. I can, for example, I can say load accumulator e count. So I'm gonna see what is the value of count. Is that okay? Then I'm gonna compare. I'm gonna compare A to 0. Okay, I'm gonna say branch if not equal to for example to 1 here. So if it comes here, that means count is equal to 1. If it comes here, count is equal to 0. Okay. If count is equal to 0, for example, this is port P, for example, so it has to be 0, 1, right? I don't care about the other bits. It has to be 0, 1. So this is if count is 0. But if count is 1, so it has to be 1, 0. Is that okay? So I have to use bit set and bit clear to do that. So I can say here, I can say bit set, okay? PTP, comma, percent, and then I can say 0, 0, 0, 0, and then here this one is related to this one. Then I'm gonna say 0, 0, 1, 0. Is that okay? And then I'm gonna say bit clear PTP percent 0, 0, 0, 0, 0, 0, 0, 1. Okay. However, in the other case, if it is 1, for sure here you have to branch. For sure you have to skip. So I have to branch this part for sure. Here I'm gonna say bit set PTP, okay, and then it's gonna be percent 0, 0, 0, 0, 0, 0, 0, 1, and then I'm gonna say bit clear PTP, comma percent. Is that okay? Anyway, is that clear? Any questions? And then, as you see, guys, the last thing I want to do here, I'm going to increment the count. Every time I'm going to increment the count, so that now I'm going to compare count to 2. If it is 2, if it is not 2, so I'm done. If it is 2, I'm going to make it 0. That's why, as I told you, the pattern of count is 0, 1. After 1, increment it is 2. And if it is 2, I'm going to make it 0. That's why it is 0, 1, 0, 1, 0, 1. Because I have 2 locations. I need 0, then 1. 0, then 1, then 0, and then 1, and so on. Is that okay? Anyway, any questions? Okay, so this is the program here. I want to teach just a second another approach for IRQ. Listen to me. What I did here, just another approach. Do whatever you wanna do. I did here in a certain way. I'm gonna explain another way. Okay. So what I did here, guys, I had number, as you see here. This number was binary. Every time IRQ is interrupted, I increment the binary number. I increment a binary number. Is that okay? And then I convert. After you increment the binary number, you have to convert the binary to decimal by dividing by 10. Is that okay? Okay, this is one approach. I have another approach. The other approach is I'm gonna use two memory locations. Okay, one is called digits, or one is at location digits. The other one is at digits plus 1. So two memory location. Okay, and then I'm gonna increment this memory location in a way so that I'm gonna keep them in decimal format. So I don't need to convert. Okay, let me clarify. So every one of these two memory location is a byte. This byte can store a value from 0 until 255, but I'm not gonna allow that. Okay, the way I'm gonna do it, every byte is gonna hold a decimal value. That means every one of them should be between 0 and 9. I'm gonna keep the format this way. Okay, I'm gonna tell you how. Look at the idea. So this is a byte. I'm gonna put here 0 and then 0. Again, I don't need conversion. All what I did, guys, I'm gonna use 2 bytes, but I'm gonna all the time when I increment them, I'm gonna keep their format to be in decimal format. That's why I don't need to convert. Okay, but I have to do increment by a different way. The way I did here increment here, I did increment for binary, right? But I'm gonna do it now in different way. Look, so this number, the way I'm gonna do it right now, as you will see, I'm gonna increment the first one. So 0 should be 1. Then I'm gonna test. If the first one after increment, if it is less than 9, okay, do nothing. I'm okay. That's it. Is that okay? So next time when I increment should be 2. When I increment is 3. Once I come to 9, increment, now it is 10. It's a byte, guys. Byte. This byte can have a value up to 255, but I'm not gonna allow it this to happen. So once it is 10, I'm gonna say, okay, you are 10. So now you should be 0, and next one should be incremented. You got the idea? So I'm gonna have 2 memory location, 2 bytes. The way I'm gonna increment them, in such a way so that I'm gonna keep them in decimal format. I'm gonna choose a code here. That's another approach here, as you see. Look here, guys. I have here, as you see, I have 2 memory location. They called the digits. This is the address of the first location. This is an array. So X is here. Okay. So 0, X is gonna give you 1 digit. 1, X is gonna give you the other digit. The way I'm gonna increment it, I'm gonna increment them in a decimal way. That's why I don't need to convert. How? As you see here, look here, guys. Number 1, I'm gonna increment the first digit, as I told you, assuming this is a least significant. So it has to be, so this is a least significant, okay? Least. This is the most. So yeah, this is similar to, for example, if the number is 11, you increment this one first. So it's gonna be 12, right? And then 13. Once this one once you increment this one is 10, no, it should be 0 and increment the next one. It's the same thing I'm gonna do right now. So now I'm gonna increment the byte pointed by X. Is that okay, guys? Then I'm gonna check. If this byte is less than or equal to 9, I am done. Do nothing, right? That's what I did here. Look here. Then I'm gonna compare it to 10. Okay. If it is less than 10, I'm done. So number 1, I have to increment the first digit. And if the result is less than 10, I'm done. I am done. Now, if after I increment the first one, for example, it was 19, I increment now, it is 1 and 10. Is that okay? So now, after I increment the 9 to become 10, right? So what should I do? So now this one should be 0, and I have to increment the next one. That's what I'm doing now. So if you go here, so now if it is 10, if the first digit is 10, so I have to clear the first digit, and then I have to increment the second digit, right? Now, what if the second digit, for example, in case of 99, so you increment this one, becomes 10, 10 is not allowed, should be 0, and then I increment the second one. What if this one is 10 as well? You got what I'm saying? So now I'm gonna clear this one. That's it. Because I have only 2 digits, not 3, not 4. That's what I do. So now, so after I increment 1, X, I need to check 1, X. Is the byte at 1, X? If it is less than 10, okay, I'm done. If not, you have to clear. So that after 99, you have to get 0, 0. You got the idea? So let me tell you the conclusion. Again, I'm teaching 2 different ways. One way, it's up to you. One way, Every time there is one interrupt, I'm going to increment a binary number. That's why I need to divide by 10 to convert the binary to decimal. This is one approach. The other approach I thought is here, I'm not going to do binary number increment. Okay, I'm not going to do that. I am going to have 2 bytes, but the way I'm going to increment the 2 bytes are going to keep them in decimal format, right? So that's why I'm going to the way I'm going to do it, I'm going to increment the first digit. If after you increment, if the result is less than 10, okay, you are done. You're okay, right? If it is 10, so I have to put here 0 and have to increment the next one. That's what I did here. Okay. Any questions? Okay, guys. Okay. So let me again, okay, see what I did here. What I did here, guys, is in this program, I want to count from 00 to 99. After 99 should go, it should go to 00. You should see the number on the 7th segment. The increment is done by RTI. Is that okay? Look, see what I'm going to do right now. What I'm going to do right now, something very interesting, okay? I'm going to just twist. I'm going to twist this program a little bit to do something different, right? But it's very interesting, okay? So what I'm going to do right now is, guys, in the next program, I want to, what I did here, I did counter. So this one is counter. Okay, counter. This one should count every time IRQ is interrupted. What I want to do right now, I don't want to do counter. I will do timer, not counter. So here I want to do timer. What timer means? So you can see the number incrementing every 1 second. Timer, right? So 0, 0, then 1, 2, 3, 4, timer every 1 second. You increment it by 1 second. Is that okay? So here what I want to do, write a program to count from 00 to 99 in the 7th segment, increment the count every 1 second, okay, using RTI, okay? So, and then IRQ should be used to stop or resume counting. You got what I'm saying? So every time I press a button, it's gonna stop counting. You press again, it's gonna count, okay? So let me choose a video before I explain the program, okay? Look here. So here I don't press anything. It's every 1 second it's incremented. Timer. Every 1 second is incremented by 1. Is that okay? Now when I press the button, I disable RTI because this counting is done by RTI. That's why I press again, I enable RTI. Disable RTI, enable RTI, disable RTI, enable RTI. Very interesting. Is that okay? So now, what's really interesting now, this program is similar to the program I taught right now, but I'm gonna shuffle things. What do you mean by shuffle things? I'm gonna tell you. That's why it's very interesting. Okay, why it's very interesting? I just shuffle things because if you see what I did here, guys, what I did in this program, increment is inside IRQ because I want to increment every time IRQ is interrupted. Okay, so I'm gonna take this one, I'm gonna put it into RTI. That's it. But every 1 second, so every 8 interrupts, as you know, every 8 interrupts, every 1 second, I'm gonna run this part. I'm gonna increment. Is that okay? All what I want to say, guys, the next program is not a new program. I'm gonna shuffle things. Instead of putting this increment part in IRQ, I'm gonna put it in RTI, so that every 1 second I'm gonna execute this part to increment. This is number 1. Number 2, what should I write in IRQ? Very simple. IRQ is gonna flip. I'm gonna flip the enable bit for RTI. So in IRQ, every time I press IRQ, I'm gonna flip the enable bit of RTI. Is that okay? Is something missing? I'm done, or something is missing? Something is missing. What's missing? One task is missing. RTI is gonna do counting. IRQ is gonna do like enable or disable to the timer. Is that okay? One thing is missing: time multiplexing. Who's gonna display on the 7th segment? RTI cannot do it because RTI already is gonna do this one. So RTI is not gonna do two things. You understand what I'm saying? So now I have 3 tasks. One task is how I can increment every 1 second, and this can be done by RTI. Number 2, how can you enable or disable counting, and this is done by IRQ. The third task is time multiplexing, and how can you display it on the 7th segment. And this part I'm gonna put it on the main program, right? So why I'm saying I'm just gonna shuffle things, because this part you can see here, I'm gonna put it in RTI. Here RTI, it's interesting. So here RTI, as you see here, RTI here is doing time multiplexing. So I'm gonna remove it from RTI. I'm gonna put it in the main program. Is that okay? Okay. So let me see now the whole program. Okay. So first, let's go to the easy one, IRQ, for example. Look, IRQ here, guys. Every time you press IRQ, debouncing, and then after debouncing, I'm gonna flip the enable bit. So that if RTI is enabled, I'm gonna disable. I'm gonna make it enabled. Is that okay? And who's gonna increment the number? RTI. So if RTI doesn't work, if RTI is not working, that means you cannot see count. There is no count. Okay. This is number 1. Number 2, if I go to RTI here, as you see here, RTI, this is exactly so look here, guys. I'm gonna increment how many number of interrupts. If it is not 8 interrupts, just leave. So I'm not gonna do anything if it is not 8 interrupts. Every 8 interrupts, look here. This is the same code I have just explained right now. So I have to, every 8 interrupts, I'm gonna come here. Okay. So every 1 second, I'm gonna increment, as I have just explained right now. I'm gonna increment the first digit. If the first digit is not 10, so I'm done. If it is equal to 10, so I have to clear. I have to clear it, and then I have to increment the next one, and so on. Okay. And now let's go to the main program. So in the main program here, guys, look here. So here in the main program, I'm gonna display. Here I'm gonna move this one from RTI from the previous program. So just for time multiplexing, as you see here, it's almost the same code. So X is here, Y is here. Still we have count, as you see here. We have count, as you see here, right? And then I'm gonna add count to Y. This is exactly the same code I have just explained right now, but this code was in RTI. Yeah, this code was here, and same thing, it was here. I'm gonna, by the way, something very tricky is, let me clear this. So I'm gonna use the same code here, guys. So I'm gonna use the same code here. I'm gonna put it in the main program. However, is that enough? It's just I'm gonna copy this part, put it in the main program. Is that enough? No, it's not enough. Why? Because after this is gonna be one iteration, and then I'm gonna go back to make another iteration. So I have to put a delay here. I should put a little delay here. But in case of RTI interrupts, I don't need to put a delay. Why? Because it's automatically, this one is gonna be interrupted, and then the next interrupt after a certain delay. So you don't need to write it, right? So I just put it here, and I am sure this subroutine is gonna be called after some time. It's gonna be called again. So I don't need to write this time, right? So if you forget to put the delay, they are gonna become dim because you are gonna be too fast. So if you see here, I'm gonna put exactly same program here, guys, in the main program. However, here I have to put a delay at the end here. This is the main difference between if you want to put it in RTI or if you want to put it in the main program. Okay, RTI already has a delay, but here you have to put a delay here. Okay, any questions? Again, I'm just asking you, can you extend this? Here, I did this program for 2 digit. For sure, you can modify it a little bit to make it 3 digit or 4 digit. Is that okay? Any questions? Okay. So what I'm gonna do right now, I'm gonna move back to chapter 3. See, are very close to finish the 2 chapters anyway. I think we finished the very difficult part of this course, hopefully. So anyway, so I'm gonna just come here to explain just what I missed here. I almost finished, but still I have to go through them again. So let me go here. So here, guys, I'm explaining. I already explained it, but I just need to go through it quickly because it. I didn't explain how can you do it in C language when you divide by. No, I explained last time, but I didn't say it here. So when you divide by 10, let me go here because you may need it to. You will need it in tomorrow. I explained it before, but I'm gonna explain it again. So here, guys. Here, when you have a binary number, okay, we agreed you have to divide it by 10 so that you can get a quotient and you get a remainder. So in C language, how I can do the same thing in C language? How can I get quotient and the remainder? Very simple. Look here. For example, I'm going to say if you have a number, and then I can say percent number, percent 10. If you do this way, so now you have the remainder. Okay. So you have here R, integer R, for example, integer R, this way. If I say R equal number percent 10, so now you have the remainder. Is that okay? How can you get the quotient? The quotient is, if I say Q equal number divided by 10. But number has to be integer. Look here, guys. If in C language, if the result of the division, this division is like 3.2, for example, and Q is float. If it is float, so it should be 3.2. However, if Q is integer, this is going to be only 3, which is the quotient. Look what I'm saying? So if you do this division, and you store the result in Q, you are going to get the quotient, not 3 point something. Okay. So anyway, this is how can you do the same operation we did here, okay, to get remainder and quotient, percent and normal division, but you have to, in both cases, this number should be integer. Okay. Anyway, so now I'm gonna elaborate on this here in chapter 3. I told you guys, if you have a binary number, okay, and if you have a binary number, you should understand very well. If I have a binary number, if I want to display this binary number in the LCD, I have to extract the digits, then convert the digits to ASCII codes. Same thing for the 7 segment, right? I also have to get the digits, and then I have to convert the digit to 7 segment code, right? So the question, how can you get these digits? As I told you, just divide by 10, right? So you have to keep dividing by 10 until the quotient is 0, right? Because and tomorrow we need to divide only 1 time, as I told you, because I have only 2 digits, right? So I can divide only by 1 time. However, for example, if you have a number like this one, okay? So as you see here, guys, if you have a number like this one, binary, so I'm gonna divide by 10. So this is the quotient and this is the remainder. So now what I did, I got 5. Okay, as you see here. So every time I divide, I'm gonna get a number from right to left. Also, this is confusing to students. Be careful. You are gonna get numbers right to left. Okay. That means if you want to display them on the LCD, you have to display them left to right, not right to left. Otherwise, if the number 1354, okay, you are going to display it 54321. You got what I'm saying? So the way I'm going to get the number right to left, but the last one I get should be the first one I write here. Okay. Anyway, so as you see here, if I get the quotient divided by 10, guys, I already got the first digit, as you see here. So now this is the number. I'm going to get the quotient divided again by 10. Yes. So now I got the second one. As you see here, every time I divide by 10, I'm going to extract 1 digit, 1 by 1, right to left. Okay. And then I'm going to divide it again by 10 and so on. Divide by 10 until the quotient is 0. Once the quotient is 0, so you are done. You don't need to continue. Is that okay? That's how I extract them. I just wanna here. This is in. You can use this approach in assembly or C language, because I told you in C language you can use percent and you can use division to do the same thing. However, in C language, as you know, we like functions. We also have some functions to do the conversion for you for C language. You will see right now. Okay, so here this is just a very simple program. I just want to show you here. We just keep dividing by 10. So I don't think I need to explain it. So here I'm telling you, you have a number stored at register G. I want you to keep dividing this number by 10, as you see here. Okay, and you store the result here in the memory location this way. So as you see here, I just put 10 in register X. I divide, and then the result, as I told you, the result, although the result should be in register G, but I'm gonna just take B. I'm gonna ignore A, right? Because I'm quite sure B, a byte should be enough, because you divide by 10, right? So maybe this confuses students a little bit, because here the quotient should be in register G. However, I'm gonna get only B, right? Yes, because you divide by 10. B should be enough. Okay. Anyway, so once I do this one, I'm gonna divide again by 10 and so on. So nothing here is new. Just I want to show every time you divide by 10. Okay, but there is one small thing you have to do here, guys, because once you do this division, the quotient is gonna go to register X. Is that okay? So what I have, in order to make another division, the quotient, I have to take this quotient divided by 10. So this quotient has to go to register D, because we divide G by X. So what I did here, I exchange it, as you see, I exchange it. So that the quotient here should go to, I move it from register X to register G to divide it again, okay? Anyway, so now I want to show you in C language. Number one, in C language, you can do the same thing in C language. You can divide, or as I told you in C language, we have functions. So yes, we have some functions that can do the conversion, okay? So for example, here exactly, I'm gonna teach two functions. One function it's called write, as you see here, write integer to LCD, right? The other one is this one is write long to LCD. So what this function is doing, guys, look here. You can just put a number here. For example, I can say 3721, and then you use this one. So this function is gonna do a lot of things. Number one, this function is gonna divide by 10 to extract these numbers, these digits, this number one. Number two, this function is gonna convert all of them to ASCII. Number three is gonna display them on the LCD. You got what I'm saying? So one function is gonna do everything. You got what I'm saying? So you just give this number, you just give this number to this function. This function is gonna display this number on the LCD. But in order to do that, it has to divide it by 10 to extract the digits internally inside this function. And then it has to convert every digit to ASCII, and then it's gonna write all of them to the LCD. Okay. So we have two of them, because one of them can use for integer numbers, the other one can use for long numbers. What is the difference? Integer numbers are 16-bit numbers, however long are 32, like bigger numbers. That's it. Okay. So for example, here I give you your examples here. Look here, guys. I have integer this variable, long this variable, and then look here, this variable equal whatever. Okay, you have to make sure it is 16-bit. Okay, so and then you just write it here. Okay, so you can see it on the LCD, and then I put the cursor. So this is in the first line. So in the first line I can see 55301, and then I'm going to use this instruction here to move the cursor to here, and then I'm going to write a bigger number. I'm going to write this bigger number here. Okay, guys, any questions? Very easy, right? Any questions? Okay. Now, I want to explain the opposite of what I did. What is the opposite? What do you mean by opposite? I'm going to tell you what I mean by opposite. Look here, guys. What I explained right now, if you have a binary number, okay, how I can convert the binary to decimal. In other words, if I have something like 1, 1, 1, 1, 1, 1, 1, 1, if you give me this number and this number, you tell me this number is a binary number, okay, and it is unsigned, so it has, you should give me 255. You give me 3 digits this way. Is that okay? However, if this one is signed, which is a different story, I'm going to explain it later, so it should be -1. We have algorithm to do that, but anyway, forget it for now. So now this is what we call binary to decimal. Okay, how I can now do the opposite and why? So we understand you need to convert binary to decimal. Why? Because computers are going to give you binary numbers. However, humans can only use decimal numbers, right? So this display here, the decimal here, I have to convert the binary to decimal. Makes sense, right? Okay, now we need to do the opposite. What do you mean by the opposite? I'm going to tell you what's the opposite, okay? Human, when I enter a number to the computer, I'm going to input this number in decimal, not binary, right? So I have to convert this decimal to binary. For example, you are going to use the keypad. You are going to ask the user, please give me a number. The user gives you 31, 32, 38, for example, okay? So the user gives you these 3 numbers, which means 128, because this number are in ASCII, 128. Is that okay? So that's what you will get from the user. That's what we call, this is decimal. That's what we're going to get from the user. So you have to convert this decimal number to binary. So this should be 10000. So how can you convert this one to this one so that computer can use it? Conversion. It's like when you translate from language to another language, humans use decimal. So when the computer gives me binary, I have to convert to decimal. When a human gives me a decimal, I have to convert to binary. Okay, that's what I'm going to explain next time. That's what we call decimal to binary. If you get decimal, how can you convert it to binary? Okay, guys. Please try to finish the test before you come. Okay, this is a test, not a lab.